Okay, good afternoon class. Okay, so this is another part of hyperbola. 5.1.4.3, the rectangular hyperbola. Okay, what does this mean? Alright, so let's see. So if we have the standard form of a hyperbola, which is x squared over a squared minus y squared over b squared equals 1. Alright, this rectangular hyperbola, okay, we discussed the one with center origin first. All right, okay, so this is hyperbola. So let's say if a equals to b, these two are the same, then the equation of the hyperbola will reduce to this form, right? Because this, since they are the same, so this one also a squared, so same denominator, we can shift it to here, right? So the equation of the asymptotes will be y equals plus minus x only, because it's b over a, remember? So this the asymptote will be this one, inclined at plus minus pi over 4 to the axis, means 45 degrees. All right, and they are perpendicular to each other. So this type of hyperbola is called rectangular hyperbola. Remember what you have done in STPM 2018 just now, the quiz, right? They want you to show that the asymptotes are perpendicular to each other. All right. So similarly, something like this. Okay. So okay, let's continue. All right, so perpendicular to each other, so the diagram will be similarly like this. All right, so this is a hyperbola, x squared minus y squared equals a squared. All right, so these two are the asymptote, and the incline 45 degree to the axis means like this. This is 45 degrees. Okay, and this one also 45 degrees. All right, and these two asymptotes perpendicular to each other. So if we have this condition, then we call this rectangular hyperbola. This is rectangular hyperbola. All right. So let's say P is a moving point on this rectangular hyperbola, and let's say the capital X and Y be the coordinate of P with the asymptote OX and OY. All right, as the coordinate axis. So you see or not? This one is the original. This one is the original x-axis and y-axis. You see, small letter. These two are the asymptote. Because they are perpendicular to each other, so we will assume that this is the new x-axis and this is the new y-axis. All right. Then the x-coordinate will be OQ. This one, OQ. All right. So and OQ is actually OM minus MQ, right? Then it will be OM minus LN, because QM same as LN. All right, and the OM here, okay, is actually ON. Where is ON? ON. OM is actually ON cos 45 degrees. Okay, so okay, I show you separately. It's something like this. You see, I draw this triangle. I draw this triangle. I draw out this triangle. All right. So this is O. This is M. This is N. I draw this triangle, and it inclined 45 degree, right? 45 degree. Okay. Therefore, from here you see that this is cos. All right, this is hypotenuse, because this one inclined, this one 90 degree. All right, so what we have is, what we want is OM and ON. All right, so OM over ON is cos 45, right? Adjacent, hypotenuse. So from here we get that OM is actually ON cos 45. This is how we get this. All right, so do the LM. So do the LN. All right, so LN is PN cos 45 degree. So I'm looking at this triangle, you see, the small one. Okay, I draw out this small triangle. This is LPN. It's like this. I draw out. So here's L, here is P, and here is N. This one, LPN. And this is 90 degree, right? Okay, and it's inclined 45. All right, so this is 45. You see, this angle and how to say it? This angle and this angle same, all right? So 45. All right. So again, this is PN and LN. Oh, so this is the angle. Oh, no, sorry. This is, yeah, correct. So this is angle. So adjacent, hypotenuse. All right, ln over pn, adjacent, hypotenuse. So cos 45. Therefore, ln is pn cos 45. This is how we get. Sorry, sine. Sine. Oh, so means the 45 degrees here. Sorry. This is the 45 degree. So it's opposite. ln is opposite. So it's sine. Alright, so sine opposite, so sine ln over pn, hypotenuse, so sine 45. So ln is pn sine 45. Alright, okay, so on here, on is x, right? You see, it's x, because the coordinate for p is xy, small x, small y, so definitely on same as x. Okay, sine 45 is 1 over square root 2. Okay, so Pn here. Pn is y, right? Y coordinate. So y over square root. Okay? Then you see xy. Just now, sorry, here. So just now we find x already. So we use the same method to find y. Okay, we use the same method to find y. So y is pq. I mean the big y, the big y. So y is pq here. Okay, so we are looking at this big capital Y axis. So Y is PQ. So PQ is PL plus QL. PL plus QL. So again, use the same concept with you draw the triangle. Okay, PL is same as MN. Of course, PL same as MN is a rectangle. Alright. So again, by using the triangle, you can see that MN is ON sine 45, PL is PN sine 45. This one both also sine. Alright, so you get this is your Y. Alright, then X multiply Y. So X multiply Y, this one multiply this one, and after you expand, you get this thing. Alright, so after we simplify, you see, since just now we get this thing, right? X squared minus Y squared equals A squared. Alright, so this one. So this is xy will be equals to half a squared. Just now we show this one already. From here. From here we show this one already. This is small letter, this is big letter. This is the difference. So remember the difference is this is small letter xy, this is big letter xy. Small letter xy is with this normal axis. Okay, capital letter xy is with this one as the axis. Alright, so hence if we rotate the rectangular hyperbola through the angle pi over 4 in the positive direction. Okay, positive direction. Positive direction means go this way lah. Positive angle direction, alright? Anti-clockwise. Then using the asymptote as the new x and y axis. So the asymptote will become the new axis. Alright, of this rectangular hyperbola. Therefore, it's now become xy equals 1 over half a square. Or we just name the half a square as c square, like in the diagram, this one. Also means, okay, originally is small letter axis xy. These are the asymptotes. So now we label the asymptote as the capital XY axis. So when we rotate, you see, this is the meaning of when we rotate. When we rotate the diagram. Alright, now you see the asymptote become the XY axis already. Okay, this xy axis is in capital letter, so we need to find one equation in capital letter, which is this one. This is why we want to find this. Alright, so after we rotate, it becomes this thing. Okay, it becomes this. So what is this? It's very familiar for you, right? This is the reciprocal graph. Remember, reciprocal graph. Which is y equals c over x. It's 1 over x graph, remember? Reciprocal graph. So means that actually this reciprocal graph is related to hyperbola. It's actually hyperbola. It's rectangular hyperbola. All right. So next, a rectangular hyperbola with this equation. This one is if the center. This one is if the center is origin. So how about if the center is not origin? All right. So in this way, standard formula, then the center will be HK. All right. And the vertices will be this one. H plus minus square root C, K plus minus square root C. This C is not the C square equals A square plus B square. No. This C is this one. Yeah, when we express the equation of the rectangular hyperbola in standard form. So this is the standard form of rectangular hyperbola. Alright, so this one will be the vertices here, these two vertices. Alright, will be with these coordinates. Okay, remember this C is not the C that in our normal hyperbola. This C come from the standard form of the rectangular hyperbola. Okay, and the asymptote will be these two, y equals k and x equals h lah. Okay, so a chord that passes through the center of hyperbola is called diameter. A chord that passes through the center means this one. A chord passes through the center means cut this hyperbola and pass through the center. So we call this diameter of the rectangular hyperbola. So the x-axis and the y-axis become asymptote, correct? The x-axis, the normal x-axis, y-axis become asymptote already. And since xy must be always positive, right? So the curve only exists on the first and third quadrant. Because first quadrant x and y both positive, so when multiplied positive, third quadrant both x and y negative, so when negative multiplied negative, still positive. Okay, so this is some extra information about rectangular hyperbola. All right, so like just now, what you have done in 2018, right? It's actually a question, something like a rectangular hyperbola. But don't worry, when you sketch, actually it's like this. Or you don't have to sketch this thing. This one is we already changed the axis. We make the asymptote become the axis. We rotate it. Then only become this one. All right. Then only become the rectangular hyperbola. If the question never mentioned rectangular hyperbola, you don't have to sketch like this. Don't worry. Okay, so let's see some example. Example 5143. So for each of the following curves, state the coordinate of the center and the vertices, then sketch the curve, showing clearly the asymptote. Alright. Okay, so I will discuss B. See, I will discuss question B. You are given x, y minus 1 equals 9. So it's in the standard form of the rectangular hyperbola. Okay, so this one. So I write it in the proper way lah, so that you see that x is actually x minus 0. So 9 is 3 squared. Alright, so the center will be 0, 1. Okay, so remember, rectangular hyperbola, we don't have to worry about x squared minus y squared or y squared minus x squared. Okay, center. Then vertices, just follow the formula. It's h plus minus square root c. So the c is from here. So c squared. Okay. Square root c squared lah. So means no need square root lah. It's actually c lah. No need square root lah. Sorry. Alright. Okay. So h is 0 ma. So 0 plus minus 3. So 0 plus 3, 0 minus 3. Okay. K is 1. So 1 plus 3, 1 minus 3. So we find the vertices. Alright. So center, vertices. This is wrong. Okay. Center, vertices. Okay. Now we sketch the graph. Okay. So can see this is a diagram. Alright, so center is 0, 1. Okay, remember the asymptote? Y equals k, x equals h. So center is hk ma. So the asymptote will be the horizontal line pass through the center and the vertical line pass through the center. So this red color will be the asymptote. So vertices is 3 and 4. Alright, 3 and 4 here. Another vertices is -3, -2, -3, -2. Alright, so you know the asymptote, you have the vertices, this is the center lah, then you draw the hyperbola. Okay. So this is not that good like the curve. So something like this will be. All right. Okay. So I will discuss one more, which is D. All right. Y equals x plus 3, x minus 3. Okay. So when you see this thing, so you know that it is improper, right? So plus 3 I can write as plus 2 plus 1. So plus 3 lah. So x plus 2 over x plus 2, 1 lah. So another part is 1 plus x plus 2 lah. Okay, you can do this way. You can do long division also, okay? So the 1, I'm going to shift it to the left hand side. So become y minus 1. Okay, so the x plus 2 shift it here, become like this. Okay, so left 1 only. So this is the standard form of the rectangular hyperbola. Okay, so center very clear is negative 2 and 1 center. Alright, so your C is 1. Therefore, it's negative 2 plus 1 plus minus 1. So negative 2 plus 1, negative 1. Negative 2 minus 1, negative 3. Okay, K also. So 1 plus 1, 2. 1 minus 1, 0. So you get the center and the vertices. Alright, so asymptote will be y equals k, x equals h ma. Alright, so x equals negative 2 and y equals 1. Alright, these are the asymptotes. Okay. So just now question B, the asymptote, I didn't write. So the asymptote is here, right? So x equals 0 and y equals 1. These two are the asymptote. Alright, so this is rectangular hyperbola. Just some extra information. So I have discussed B and D. Alright, so you do A and C as homework related to rectangular hyperbola. Alright, so this video, the lesson, I will stop here. It's just a simple one to introduce rectangular hyperbola. So basically, we have learned all the basic about the conics, the standard form and the general form of the conics, means the circle, ellipse, parabola and hyperbola. The equation of the standard form and general form, and from the equation how we can get the center, the vertices, the asymptote, okay, and so on, the directrix. So basically we have done, so you have know the 4 types of conics: circle, ellipse, parabola and hyperbola. Alright, so tomorrow onwards we will go to another part, 5.2, parametric equations. We're still doing these 4 conics. We're still doing the same 4 conics, which is circle, ellipse, parabola and hyperbola, but the equation will be in parametric form. We use parametric equation to represent these 4 conics. Alright, so this part also very important. It came up many past year question, STPM question from this part. Alright, okay. Thank you, class.